Good evening, everyone. So today I'm going to work on another example problem for revised simplex method. And today we are going to work on the two-phase method by using the revised simplex method. Okay? And I want you to keep in mind for the revised simplex method, if you know the initial tableau and basis set and the basis inverse matrix, then you are able to compute any part of the tableau corresponding to the current basis set. Okay? And these two screens shows the detailed steps of revised simplex method. Okay. And today we are going to solve this problem using two-phase method. Okay, so like you see here, because the lack of slack variables for each of these three constraints, we must use the phase 1 to find the initial basic feasible solution, right? So by subtracting the surplus variable from the second constraint, okay, let's see, this is constraint number 1, number 2, and number 3. So first of all, we need to standardize it, which means all the greater than equal constraint should be equality constraint by introducing the surplus variable, right? The constraint number 2 becomes this minus, let's use x7 variable, okay? Becomes 12. Likewise, the third constraint becomes 4x2, 2x3, 3x4, x5, and let's use x8 as the surplus variable for this constraint, and it becomes 15, right? And we should add artificial variable to every constraint, right? Which means our constraint set becomes 2x1 minus x2, x4, 3x6, plus x9. That is the first artificial variable. And second constraint becomes x1, 3x3, x4, 3x5, 2x6, minus x7 plus x10, right? In that case, x7 is the surplus variable and x10 is the artificial variable, right? And the last constraint becomes 4x2 plus 2x3, 3x4, and x5. Subtract the surplus variable x8 and add artificial variable, which is x11, right? Of course, all the variables are greater than equal to 0. And we need to find a basic solution which has all the artificial variable, which is x9 equals x10 equals x11 equals 0. That's why we should introduce phase 1 objective, which is W. That is the minimizing the sum of all these three artificial variables, right? x9, x10, and x11, right? And for the ordinary simplex method, the pivoting was required to eliminate these artificial variables from the first row, right? Objective function row. However, in the revised simplex method, you don't need to do it, okay? And we introduce three artificial variables because we want them to be an initial basis. Initially, the basis set B becomes 9, 10, 11. And the non-basis set, let's say MB becomes 1, 2, 3, 4, 5, 6, 7, and 8. Okay? So here, what does the current basis set? B equals 9, 10, and 11. This means the first element of B, which is 9, is the basic variable in the first constraint, which means x9 variable is the basic variable in the first constraint. Likewise, x10 is the second basic variable, right? And x11 is the basic variable in the last constraint. So we begin the first iteration of phase 1 by computing the basis inverse matrix.
Excuse me?
Yes?
So we are not going to prove the Z to be also a part of the base?
Well, yeah, we were going to include that. So, sorry, because there is no space, I didn't include here. But like you said, we still have original objective function right here, right? Okay, thank you. So, based on this, we can construct the initial table like this, right? So the first row is the phase 1 objective function row, and the second row is the phase 2 objective function row, and three constraints, right? And in here, x8 and x9 are the surplus variable. No, 7 and 8, right? Thank you. Okay, so 7 and 8 is the surplus variable, and x9, 10, 11 are the artificial variable, right? And the initial basis set B is 9, 10, 11. Okay? And the basis set B equals 9, 10, 11 tells us the basis matrix A superscript B is this 3 by 3 matrix, right? 1, 0, 0, 0, 1, 0, 0, 0, 1. You remember? Because the basic variable columns of the constraint coefficient matrix, which is this, these are the basis matrix. Okay? And because this is the identity matrix, the inverse matrix is same, right? Now we are ready to begin the first iteration of phase 1. Because we have initial tableau and basis set and basis inverse matrix, right? So let me write down the iteration number 1 and step number 1. What is our first step? Compute the simplex multiplier vector, which is pi, right? And we can use the formula CB and basis inverse matrix, right? Which will be used in pricing the non-basic variable, right? And this CB is the objective coefficient vector, corresponds to the current basis, right? So what is that? Should be 1, 1, 1, right? You remember? Because we are dealing with phase 1, our objective function row would be this first row, right? So CB is 1, 1, 1. Okay? And then basis inverse matrix is 3 by 3 identity matrix. Which leaves us 1, 1, 1. Okay? This is the pi value. And last time we've learned that this pi value, simplex multiplier, provides the dual solution, right? Then what is step number 2? We need to compute the reduced cost. Actually, in that case, reduced artificial cost, right, of the non-basic variable. Because we are dealing with the phase 1. That is the artificial objective function, right? So compute reduced, let's say, artificial cost. Okay? They can be obtained by the objective coefficient minus simplex multiplier pi times the coefficient matrix A, right? So what is this part? Objective coefficient for non-basic variables. Those are this, right? So we have 8 zero vectors, right? 1, 2, 3, 4, 5, 6, 7, 8. Minus pi, which is 1, 1, 1, right? What is this A? That is the coefficient matrix for non-basic variables. Must be 3 by 8 matrix, right? So it's going to be 2, 1, 0, minus 1, 0, 4, 0, 3, 2, 1, negative 1, 3, 0, 3, 1, 3, 2, 0, 0, negative 1, 0, 0, 0, negative 1. Okay? Then we will obtain negative 3, negative 3, negative 5, negative 3, negative 4, negative 5, and 1, 1. Okay? As a result. And because this reduced cost of x1, x2, x3, x4, x5, and x6 are the negative, increasing any of these variables would improve phase 1 objective function value, right? Which means it will decrease the current phase 1 objective function value, right? So one of these 6 variables would be accepted as a pivot variable, right? So step number 3, we arbitrarily select, let's say x3, okay? To enter the basis. Okay? So x3 column becomes the pivot column. Okay? So our current table can be updated with negative 5 here, right? Next, you need to determine the leading variable by performing the minimum ratio test. And the vector of substitution rate of x3 variable is represented by alpha, right? The corresponding formula is basis inverse matrix times the coefficient vector A. Okay? Actually, the entering variable is x3 variable, so must be A to the superscript A, 3. Right? Basis inverse matrix is 3 by 3 identity matrix currently. What about this A3? That is 0, 3, 2, right? So the alpha must be 0, 3, 2. Okay? So we may update the current table with this value 0, 3, 2. Now we should get the right-hand side values to perform the minimum ratio test, right? And the values of the current basic variables can be obtained by beta, right? Or the basic variable values. They are currently x9, x10, and x11, right? And it can be obtained by basis inverse matrix times the right-hand side value from the original table, right? So it should be 10, 12, 15, okay? So it becomes 10, 12, and 15, okay? And from the minimum ratio test, the first one can be discarded because it's 0. Second one is 12 over 3. Third one is 15 over 2. So minimum occurs at this, right? Which is 4. And because the second ratio is minimum, the second basic variable, which is x10, right? Second basic variable, x10, is replaced by the entering variable, which is x3. And the new basis becomes 9, 3, 11. Right? So you have a new basis. B is 9, 3, 11. What about the basis matrix? What value should we use? What about the first column of the new basis matrix? Is the constraint coefficient corresponding to the first basic variable, x9, which is 1, 0, 0, right? What about the second column of the new basis matrix? 0, 3, 2, right? And the third column should be 0, 0, 1, right? And now we need to update the basis inverse matrix. And we've learned the basis inverse matrix can be obtained by taking by updating the old basis inverse matrix, right? So first, we need to write down the old basis inverse matrix. And then write down the pivot column on the other side of this matrix. So it looks like 1, 0, 0, 0, 1, 0, 0, 0, 1. And alpha value is 0, 3, 2. Okay? Then we should make this part to 0, 1, 0. Right? And last time I've used Excel to do that. And let me do this again. 1, 0, 0, 0, 1, 0, 0, 0, 1, and 0, 3, 2. Right? And this is the pivot column, right? And this is the pivot row, and this becomes pivot cell, right? Which means the next iteration, this part becomes 0, 1, 0, right? So first of all, the pivot row, the row number 2, must be divided by 3, right? And then the first row should be replaced by... No, it doesn't need any changes, right? Because we already have 0. The third row must be replaced by 2. The third row minus the pivot row times 2 over 3, right? And copy that formula and paste it. And this part must provide the new basis inverse matrix. Okay? I'm sorry?
First row.
Yeah, first row looks weird. Okay, let me just copy this and then paste it. Okay, thank you very much. Right, this is the new basis inverse matrix. So, from this, we've got the new basis inverse matrix, which is another 3 by 3 matrix, 1, 0, 0, 0, 1/3, negative 2/3, right? And 0, 0, 1. Now we are ready to begin another iteration of the revised simplex method for phase 1, right? So, iteration number 2. The first step is to compute the simplex multiplier vector pi what is the CB? Should be 1, 0, 1, right? The basis inverse matrix 1, 0, 0, 0, 1/3, negative 2/3, 0, 0, 1, right? So the pi value should be 1, negative 2/3, and 1. Okay? This is our new simplex multiplier vector. Step number 2, compute the reduced artificial cost for the non-basic variables. Right? So again, it can be obtained by objective coefficient for non-basic variables minus the simplex multiplier vector times coefficient matrix A. Right? So let me write down. Currently the non-basic variables are x1, x2, x4, x5, x6, x7, x8, and x10, right? What about the objective coefficient for those variables? Zero, 0, 0, 0, 0, 0, 0, and 1, right? Minus simplex multiplier vector 1, negative 2/3, and 1 times the A matrix constraint coefficient for all these non-basic variables. Okay? So it must be 2, 1, 0 and negative 1, 0, 4 and 1, negative 1, 3 0, 3, 1 and 3, 2, 0 0, negative 1, 0 0, 0, negative 1 and 0, 1, 0. Right? And we will get the solution as negative 4/3, negative 3, negative 14/3, 1, negative 5/3, negative 2/3, 1, negative 5/3. Okay? And because the reduced cost of x1, x2, x4, x6, x7, and x10. So the negative, one of these 6 variables would be accepted as a pivot variable, right? So next step is to choose the entering variable. So we just arbitrarily select x4 to enter the basis. Okay. So our current table becomes negative 14 over 3, right? Next, you need to determine the leading variable, right? So we should get the substitution rate, alpha. So we will have basis inverse matrix. What about A4? A4 is 1, negative 1, 3, right? And this should be 1, negative 1/3, 11/3. If my calculation is correct. So we can add this value to the current table is 1, negative 1/3, 11/3. Okay? And the right-hand side value, beta, can be obtained by basis inverse matrix times the right-hand side value from the original table, right? It should be 10, 4, 7. So we have 10, 4, 7 right here. Now we are able to do the minimum ratio test, which is 10 over 1, and second one is not considered because we have a negative value here. Third ratio is 7 over 11/3, right? So should be 10 21 over 11, right? So this should be the minimum value, the third one. Because the third ratio is minimum, the third basic variable, which is x11, is replaced by the entering variable, which is x4. Okay? And the new basis becomes nine, 3, 4, right? Then what about the basis matrix? What is the first column of the basis matrix? 1, 0, 0, which is from x9 column, right? 1, 0, 0. And the third column should be 0, 3, 2. The last column is 1, negative 1, 3. And the same way, we may obtain the basis inverse matrix by updating the old inverse matrix. Okay? And according to my calculation, the new basis inverse matrix is 1, 0, 0, 2, 11th, 3, 11th, negative 2, 11th, and negative 3, 11th, 1, 11th, and 3, 11th. Okay? Now we are ready to begin the third iteration of phase 1, right? Because we have initial table, new basis set, the new basis inverse matrix, right? So, iteration number 3. And step 1 is again compute the simplex multiplier vector pi. Okay? What is the value of CB? what is the objective coefficient vector corresponds to the current basis set? Is 1, 0, 0, right? 1, 0, 0. The new basis inverse matrix, which is this. Then we will have 1, 2 11ths, negative 3 11ths as a simplex multiplier vector. And repeat the same step, step 2, which is compute the reduced artificial cost of the non-basic variables. Currently, the non-basic variables are the x1, x2, x5, x6, x7, x8, x10, and x11, right? And the objective coefficient relative to these non-basic variables are the 0, 0, 0, 0, 0, 0, and 1, 1, right? Minus the simplex multiplier vector, which is this 1, 2 11ths, negative 3 11ths, times constraint coefficients corresponds to all these non-basic variables, right? So must be 210, negative 104, 031, 320, 0, negative 10, 00, negative 1, 010, and 001, right? And according to my calculation, these values are negative 2.182, 2.091, negative 0.273, negative 3.364, 0.18, negative 0.27, 0.82, 1.27. Okay? And again, because the reduced cost of x1 and x5, x6, x8 are the negative. So any of these 4 variables could be accepted as a pivot variable, right? So our current table, we should select the entering variable first, right? So let's arbitrarily select x6 to enter the basis. Which is the most negative value, okay? And we have negative 3.364, 0.364 right here. Okay? Next, we need to determine the leaving variable. So first of all, we need to compute the substitution rate alpha. We have basis inverse matrix right here, and the constraint coefficient for x6 variable, which is 3, 2, 0. So we have 3.364, 0.546, negative 0.364. Okay? So we can add this value to the current table, which is 3.364, 0.546, negative 0.364. Okay? And the right-hand side values of current table can be obtained by beta, which is obtained by basis inverse matrix times the right-hand side value from the original table, right? And it must be 8.091, 4.636, 1.909. Okay? So we can update the table with this value, 8.091, 4.636, 1.909, right? And from the minimum ratio test, the minimum occurs at the first ratio. Okay? Which means the first basic variable, which is x9 variable, is replaced by the entering variable, which is x6. Okay? Therefore, the new basis becomes 6, 3, 4. Right? And we have new basis matrix, A superscript B. What is the first column? 3 to 0, right? Second column is 0, 3, 2. And the last column is 1, negative 1, 3. Right? And as we did earlier, the basis inverse matrix can be obtained by updating the old basis inverse matrix, right? And it must be 0.297, 0.162, 0.108 is the first column. Second column would be 0.04554, 0.243, negative 0.162. The last column is negative 0.081, 0.135, 0.243. Okay? Any questions so far? Okay, now if you look at this screen, then it's easy to see that all the artificial variables, which are x9, x10, and x11s, oh, I'm sorry, this is the initial table, right? Hold on a second, please. Okay. Not from the initial table, but just look at the new basis set. Because the new basis set is 634, which tells us currently the non-basis set would be 1, 2, 5, 7, 8, 9, 10, and 11, right? Because all the artificial variables, x9, x10, and x11s, are non-basic variable, right? Which means we are able to complete. Well, we've already completed the phase number 1, right? Because artificial variable x9, x10, x11 is 0. Because all of them are the non-basic variable, right? What about the phase 1 objective function value, W? W is the summation of all these artificial variables, right? 9, 10, and 11 is also 0, right? So we may say that the original problem is not invisible, right? So we are able to begin the phase 2 right now. In phase 2, of course, we can ignore all the columns. Oh, I'm sorry, x8 is not the artificial variable, right? We can ignore all the artificial variable columns. The phase 1 objective function row, right? Like this. The current basis set is 634. Let's say this is phase 2, okay? And the basis inverse matrix is, let me rewrite down here, .054, .243, negative .162, negative .081, 0.135.243. Okay? So let's say this is the iteration number 1 in phase 2. Okay? Again, the first step is to compute the simplex multiplier vector, which is pi. CV, the basis inverse matrix. What is the objective coefficient vector? Corresponds to the current basis set. Should be 4, 7. Is that right? Because we are in phase 2, we don't use the phase 1 objective function rho anymore, right? And then we use the basis inverse matrix, which is this. Okay? And in my calculation is 1.2973.0545 1.9189. Okay? Next step is to compute the reduced cost for non-basic variables. Currently, the non-basic variables are x1, x2, x5, x7, and x8, right? The objective coefficient corresponds to these non-basic variables are the 3, 5, 5, 0, and 0, right? Sorry? Is that right? Okay. Thank you. Minus the pi, which is this, right? Pi vector times the constraint coefficient relative to these non-basic variables. So the first column should be 210. Second column is negative 104. Third one is 031. Next one is 0, negative 10. And the last one is 0, 0, negative 1, right? And in my calculation, the answer is 0.351, negative 1.378, 2.919, 0.054, and the last value is 1.919. Okay? Oh, we still have negative reduced cost for x2 variable, right? So x2 variable must be accepted as a pivot variable. And next step is selecting the entering variable. We've already determined entering variable, which is x2, right? So the current table becomes negative 1.378. Okay? Sorry, I should delete this row, this column, and the last 3 columns, right? Next step is to compute the the substitution rate, right? And what is this? A superscript 2 is negative 104, right? Anyway, I've got negative 0.6216, 0.7027, 0.8648. Okay? So we can update the table with this value, negative 0.6216, 0.7027, 0.8648. Okay? And the value of current basic variable, which is represented by beta, can be obtained with this formula. And again, B is from the original table, right-hand side values, right? And I've got this value, 2.405, 3.324, and 2.784. Okay? So I have this value, 2.405, 3.324, 2.784. Okay? And we are able to do the minimum ratio test. The first ratio is discarded because we have negative value here. Second ratio is 3.324 over 0.7027. The last ratio is 2.784 over 0.8648, right? And I believe the minimum value occurs at this ratio, the third ratio. And this means the third basic variable, which is x4 variable, will be replaced by the entering variable. What is the entering variable? Which is x2 variable, right? So the new basis is 6, 3, 2, right? I believe this must be the last iteration. So the new basis matrix would be obtained based on this new basis set, right? The first column is the constraint coefficient belong to the first basic variable, which is x6. So 3, 2, 0. Second column is constraint coefficient relative to the second basic variable, x3, right? So 0, 3, 2. Likewise, the last column becomes negative 1, 0, 4. Okay? Now, we need to update the basis inverse matrix the same way. I've got 0.375, negative 0.25, 0.125, and the second column is negative 0.063, 0.375, negative 0.188, and the last column is 0.094, negative 0.063, 0.281. Okay? Now, again, because we have initial table, new basis set, new basis inverse matrix, we are able to begin the second iteration of the phase 2. Okay? Well, I think I'd better stop here for today because I plan to talk about a little bit more right after we solve this problem, which is about duality. So I'm going to finish up for the rest of the part next time. And from next time, I'm going to talk about the sensitivity analysis, okay, which is another very important topic in linear programming. Okay, thank you. We'll see you next time.